this video has sound. Hopefully everybody can hear my voice. Otherwise they're reading this sign and trying to hopefully get the sound up and running. This is a lesson on Chapter 7, Section 4, Part 1 out of the Geometry Chapter 7 Study Guide. This one has to do with a special type of right triangle. It is called a 45-45-90 triangle because the angles in the corners are 45 degrees, 45 degrees, and 90 degrees. So it turns out that there's a relationship between the leg lengths. Remember, the leg lengths are the sides in the triangle, or the legs are the sides in the triangle, are the ones that come together to form the 90-degree angle, right? So these two sides would be our legs because there's the 90-degree angle. It turns out that on this special type of triangle, when we can see 45 degrees, 90 degrees in the corners, that the hypotenuse is always going to be the square root of 2 times as long as a leg. So as an equation, we could say that the hypotenuse equals a leg times the square root of 2. Or, as I like to write it, hypotenuse equals square root of 2 times leg. Same thing. Okay? So here in example A, if we want to figure out how long the hypotenuse is, that's this one, I'm going to call that H. And our formula says, hey, is this a 45-45-90 triangle? Yeah, it is, because if this is 90 and this is 45, that must mean that there's only 45 degrees for this corner to be if you add them all up to 180. So this is indeed a 45-45-90 triangle. So the formula says that the hypotenuse equals the square root of 2 times a leg length. So I'm going to call that L. So one of our legs is 6. The other one would also be 6 on this type of triangle because it is isosceles. So the hypotenuse would equal the square root of 2 times 6. Now when we write our answers, when one part of our answer is radical form, the other one is not, the radical always comes after. So it would be 6 and then root 2 for our length of our hypotenuse here. Here again they want us to find the length of the hypotenuse H. As long as this is 90 degrees and the two sides next to that are equal, then this is indeed a 45-45-90 triangle. Isosceles right triangles are 45-45-90 triangles. These angles have to be 45 and 45. So finding the hypotenuse, we can use our formula that the hypotenuse equals the square root of 2 times a leg length, either one. They're both the same, so it doesn't matter. So hypotenuse equals the square root of 2 times the length of a leg is 4 root 2. Now if you multiply the square root of 2 times the square root of 2, you get the square root of 4. And 4, just bring that down. The square root of 4 is actually simplifiable to be just regular 2, right? This is this. So if I multiply, which I can now because they're both regular numbers, 2 times 4, we get 8 for the hypotenuse on example B. So you can do this process several times. There's several more examples, 1 through 1, 2, let's call this number 3 and number 4. Finding the hypotenuse here and here will be pretty easy. This is our hypotenuse. I'm going to change it to H instead of X. Hypotenuse equals the square root of 2 times a leg. So that would be the square root of 2 times 4. So that would be 4 root 2 if we write it in the correct order, right? Or on number 2, this is clearly a 45-45-90 triangle. So the hypotenuse is the square root of 2 times a leg length. The leg length is 6. Again, these are the legs. They come together to form the 90-degree angle. So that would be the square root of 2 times 6. So our hypotenuse length is 6 root 2. Or here, at number 3. The hypotenuse, I'm going to call that H. Again, this one was H. hypotenuse is the square root of 2 times the leg length. Oops. So our legs here have a length of 12, so root 2 times 12. In the proper answer format, it would be 12 root 2. Okay. Now, what happens if we have a triangle where they've given us the hypotenuse? So, for example, right here, we have a 45, 45, 90 triangle. I know that because it's isosceles. Do you see how the two legs are the same length? When the two legs are the same length, then these two angles have to be identical, which means they split the remaining 90 degrees from the 180 that is the sum of the interior angles here. So each of these have to be 45. So because C is the same length as this one and this one and this one, basically what they're asking us to do, C and this are the same thing, so I'm just going to label this one C as well. So in order to find C, that's one of the legs on this 45, 45, 90 triangle. So if I set up my formula, I'm going to use this space over here. Hypotenuse equals the square root of 2 times the leg length. The leg length is the thing we don't know, so that would be C. And hypotenuse, that's this one, 24. That's what we do know on this triangle up here. So how do we figure out what C is? Well, if I write it the other way around, it would be square root of 2C equals 24. And we would solve this by dividing both sides by the square root of 2. Now this is something kind of unusual. I don't know how much solving of equations that you've done using this square root as your divisor. But basically we start off with this, the square root of, or 24 divided by the square root of 2. So how does that simplify? Well, here's how you do it. You take the square root in the denominator here, and you take that value and you multiply it on the top and the bottom of your fraction. Then we multiply straight across. 24 times the square root of 2 is just 24 root 2. And on the bottom, the square root of 2 times the square root of 2 is the square root of 4, right? The square root of 4 is just regular old 2. And then all we have to do is divide if we can. 24 is divisible by 2, so we can divide the top by the bottom by just taking 24 divided by 2, which is 12. The square root of 2 just comes along for the ride and becomes part of our answer. So length C, which is the same as this, this, and this, is 12 root 2. Length D, I know that that's 24 because this is a square. How do I know this is a square? Because this corner is 45 degrees, and this corner is 45 degrees, and that one's 45 degrees, and that one's 45. So each one of these triangles is identical, and each little corner here is 45 degrees. And what does 45 and 45 add up to? Bam, 90 degrees, right? So I've basically proven to myself that each one of these corners in this quadrilateral, the four-sided shape, are 90 degrees. And so since it's a square, I know that all of these sides would have to be the same length. So D has to be the same as this side, 24. All right, now completing the table, it's kind of like doing these problems over here, just several times over. So here's the first question. They want you to assume that x is 5 and they want you to find y. And then the next question, they want you to assume is y is 4 root 2 and they want you to find x. And then this is the next question. They want you to assume that x is square root of 2 and they want you to find y. So it's basically 5 questions. 1, 2, 3, 4, 5. Okay? So if the leg length was 5, then how long is the hypotenuse? That's the question here. So if the leg length is 5, the hypotenuse would be 5 root 2. So there's the answer to the first question. How about this one? If the leg length is 9, because again you see the x on the diagram, these are the leg lengths here. How long is the hypotenuse? They want you to find y. Well, that would be 9 root 2. Remember, I'm just flipping these around because when you have a radical portion of your answer, that comes last. So how about this one? We're going to find a leg length here. I'm doing the second problem. So if the hypotenuse is 4 root 2, and we don't know how long the leg is, L, well, 4 root 2 equals the square root of 2 times L. You can think of this in a couple ways. 4 times the square root of 2 is the same as the square root of 2 times what? If just mentally you're like, that would be 4, because 4 times root 2 equals root 2 times 4. It's just the opposite order, but when you multiply, same thing, right? Or if you're not quite sure what L would be just by looking at it, what you can do is solve it as an equation. I would write it that way, and then I would divide both sides by the square root of 2. And so the leg length here, these two would cancel. And then these two would cancel and you would get 4. So in the second problem, the leg length would be 4. Here's the third problem. They tell us the leg length is the square root of 2. So we have hypotenuse equals the square root of 2 times the leg length on a 45, 45, 90 triangle. So the leg length is the square root of 2. So the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 can be simplified to be just regular plain old 2. So hypotenuse is 2. And then the last one, they want us to find the leg length, x, if y, the hypotenuse, is 24. So hypotenuse equals the square root of 2 times the leg length. Alright, so the hypotenuse is 24 equals root 2 times L. So I think I'm going to have to solve it like an equation like I did up here. This one just mentally doesn't just go, oh, there's the answer. This one, you may have figured that out just by looking. So let's see, I'm going to write it the other way around. I'm going to say that the square root of 2 times the leg length equals 24. And then I'm going to divide both sides by the square root of 2. Which gives us 24 divided by root 2. And you simplify in exactly the same way as you did on number 4 on the bottom page, or the bottom of the previous page, right here. So all you do when you have a square root in the denominator is multiply on the top and the bottom by that radical. And then the square root of 4 is 2. And I'm talking quickly because I already talked about exactly these numbers on the other page. And then you divide 24 by 2, which is 12. And then the last example for this section is a real world problem. And it basically says that this roof has a 1-to-1 pitch, which means that for every foot that it goes in towards the center of the house, it goes up 1 foot. Now, what that means is that you're going to have a special type of triangle once you get to the top of the roof line. Okay? So if every 1 foot you go over is the same as 1 foot up, first of all, you're going to get a 90-degree angle right here. This is the triangle that I'm drawing, by the way. Okay, just making it bigger. And if you go over 1 foot and up 1 foot, that gives you a 45-degree angle. Because 45 degrees is a perfect diagonal. And if this is 45 degrees and this is 90, that must mean that this would have to be 45, because in order for them to add up to 180 degrees, if this is 90 and 45, then that's 45. Now I didn't draw the pitch of this roof perfectly. I'm going to actually just adjust that slightly so we have a better diagram here. Okay. So with this triangle, I'm hoping that since we've recognized our 45, 45, 90 triangle, we can use some of the relationships here in order to find some things they want us to find. For example, in part A, they want us to find the values of x and y. Well, I'm assuming if they've built this house in a manner that makes sense, that these two sides of the roof would be the same. It looks like a symmetrical house, that it's the same on the left side as it is on the right side looking at the front. So I'm assuming x and y are the same amount. Now, finding x, if we know something else about this triangle, for example, if this length all the way across here is 24, then, and if this is the midpoint, then this distance here would be 12, and then this distance here would be 12, right? Because it's exactly halfway, based on the symmetrically arranged front side of the house. So that means that this length right here is 12. And this one right here then would also have to be 12, because 45, 45, 90 triangles are isosceles. So if I want to find the length of x, that's the hypotenuse side. Remember the formula is hypotenuse equals the square root of 2 times the leg length on a 45, 45, 90 triangle. So since the leg length is 12, the hypotenuse then would be square root of 2 times 12, or properly formally written, 12 root 2. So that's the length of x, and it's also the length of y. And there's my answer to part A. Part B asks me to find the area of the roof. Well, the roof basically is two rectangles. You see one rectangle here, and then on the other side would be another rectangle. So basically, the rectangle that we can see, this one right here, this side down here is length y, which we know is 12 root 2. And this side right here would be the same as the base of the house, 35. So to find the area of a rectangle, we would just go length times width, right? So that would be 35 times 12 root 2. So that gives us, if I multiply the numbers I can multiply together, 35 and 12, that gives you 420 times the square root of 2. And if I take 420 times the square root of 2 on my calculator, I get approximately 593.97 square feet. But remember, that's just this side of the roof. We have another rectangle on the other side of the roof that's the same amount. So the whole roof is made up of two of these rectangles. So I'll take my value that I found here and double it. So I get an approximated answer of 1,187.94 square feet, but they want us to round that off to the nearest square foot. So that's about 1,188 square feet.